Hello everyone. So far we discussed electric field due to group of point charges. When charges are discrete, that means we can distinguish charge Q1, Q2, Q3. Uh, so due to this discrete charge distribution, what is the expression of electric field at the point P? So we came to know that this is the summation 1 by 4 pi epsilon naught summation over I equal to 1 to n Qi by Ri square Ri cap. So this is the expression of the electric field when charges are discrete. But when charges are not discrete, they are distributed, or we can say this is charges are continuously distributed throughout the line. So for this continuous charge distribution situation, let us consider this. Let us consider this line charge distribution, and we will take small element dl. So from this coordinate system, let us say this small element dl is at a distance r1 vector, and the point P where we will calculate the expression of electric field is at a distance r2 vector. Position vector is r2 vector, right? So is the separation of this the distance between this line element and the point P is is r21 vector, which is equal to r2 vector minus r1 vector, right? So let us consider, let dl be the small element. This small element is dl. So where lambda is charge per length, then charge on the element dq, on the small element dq, is equal to lambda dl, because lambda is the charge per length. So dq will be, so dq here, dq this small in this small element, dq is lambda dl, dq is lambda dl. So now the force on the test charge. So here we consider test charge plus q naught. So the force on the test charge plus q naught due to the charge dq. So the force between this plus q naught and dq. So from Coulomb's law, it is clear that the expression of force will be df vector, because this is due to the small element dq charge. So df vector is equal to 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught q naught dq by the separating distance, which is nothing but r21 square, r21 cap. Then the total force, then the total force due to this whole line element, the total force will be, so the total force will be F vector is equal to integration of df, as this is continuous charge distribution, so we'll integrate it. That's why integration over df, which is equal to q naught by 4 pi epsilon naught integration, is a line integration, lambda dl by r21 square r21 cap. So from this expression, we can find out the expression of electric field. Electric field is equal to the force divided by test charge q naught. So electric field is equal to, so expression of electric field is equal to 1 by 4 pi epsilon naught line integration, this is lambda dl by r21 square r21 cap. So this is the expression of electric field. This is the expression of electric field at the point P due to this line charge distribution or linear charge distribution. Now, when charges are distributed throughout the surface, so surface charge for the surface charge distribution. So let us consider a surface in which charges are distributed, plus positive charges are distributed. So we will take a small element ds, so which is at a distance. So from the, so position vector is r1 vector, and the point P where we want to calculate the expression of electric field due to the surface charge distribution. So it is position vector is r2 vector, and the separating distance will be simply r21 vector, which is nothing but r2 vector minus R1 vector. So we will take the test charge plus Q naught at the point P. So we want to calculate the expression of electric field at the point P. So here also, this in this small element dq, small element ds, we will take the charge. The charge will be dq is equal to sigma ds, where sigma is charge per unit area. So due to this small element, force will be the force between this small element ds, where charge is dq, and the test charge q naught is equal to, so force is equal to, so df vector is equal to, from Coulomb's law we know, is equal to 1 by 4 pi epsilon naught q naught into sigma ds by r21 square r21 cap. So the total force on the charge dq will be, the total force in the same way, total force will be, total force due to the surface charge distribution, due to this surface charge distribution, total force will be, so we'll integrate it, integration over df vector, which is equal to q naught divided by 4 pi epsilon naught integration over the surface is sigma ds by r21 square r21 cap. So from here we can easily know what is the expression of electric field. So expression of electric field will be 1 by 4 pi epsilon naught integration over the surface is sigma ds by r21 square r21 cap. So this is the expression of electric field due to the surface charge distribution. Now volume charge distribution. When charges are distributed throughout the volume, in that situation, what is the expression of electric field at the point P? So here also we will take a test charge Q naught. What is the expression of electric field at the point P? So from the coordinate system, the position vector is R1 vector. We will take a small volume element. So this is volume element is called dV. So in this volume element, the charge is in the volume element is dq. So dq is equal to rho dV. So and also the position vector of the point P is R2 vector. So the separating distance is R21 vector, which is equal to R2 vector minus R1 vector. Right. So here dq is rho dV, where rho is called charge per unit volume. Charge per unit volume, right? So due to this small element, what is the expression? What is the expression of force at the point P? So from the Coulomb's law, we know the F vector is equal to 1 by 4 pi epsilon naught q naught rho dV by r21 square r21 cap. So the total force F is equal to integration over dF. So this is a volume integration, and it was surface integration. Here it is volume integration. So total force is equal to 1 by 4 pi epsilon naught integration over the volume. This is q naught rho dV by r21 square r21 cap. So the expression of electric field is equal to 1 by 4 pi epsilon naught integration over the volume V rho dV by r21 square r21 cap. So we have the expression of electric field due to the volume charge distribution. We have the expression of electric field due to the surface charge distribution, and we have the expression of electric field due to the line charge distribution or linear charge distribution, right?